Okay, so today we're going to learn about the scientific method. Hopefully you guys have been doing some form of this since you were in elementary school. You all should, but we all have different forms of it. But basically, though, it all follows the same line. The whole point of knowing what the scientific method is figuring out how scientists have came up with these theories that we're going to learn about through the year and how we can interpret their data. That's the most important thing, okay? Nowadays, you guys can all look up almost any information at your fingertips online. The point of knowing the scientific method is being able to interpret those results. Okay, yeah, we might have all the data and we might have all the information, but if you don't understand where it came from or how to understand it and apply it to something in the future, then the whole purpose of having that information is really pointless, okay? The whole point to have information is to be able to apply it to our future or predict something that might happen, okay? If we all have this data now about the coronavirus. If we had it before, we might have been able to do something to prevent the big spread of it. Okay, we have to be able to interpret the data. But again, right now, America and the rest of the world is running through the scientific process. Okay, the very first step is a question. Okay, very, very, very first step. So that's that Q. Okay, I like to focus a lot on QHTRC. Okay, I think it's easier to remember letters instead of a bunch of words. Okay, so Q is your question. Okay, and again, our question, so let's just stick with the coronavirus since that's what we're dealing with right now. Okay, our question is, how can we stop the spread? All right, then that's the very first thing you ever do is, what is the problem? What's the question? Okay, then you move in and you make a hypothesis, which is an educated guess. Okay, and hopefully you guys have written these before, and you write them in an if-then statement. Okay, an example for the coronavirus would be, if I wear a mask, then it will stop the spread. Okay, that's just a guess. We don't really know till we test it out. Okay, that's what the T stands for, is test. Okay. We're testing it. Some areas are testing it more than other areas. Okay, my friend in Chicago, she can't come visit me because Missouri doesn't follow the rules according to the way we're supposed to. So Chicago says, nope, if you do that, then you have to quarantine yourself for 2 weeks. And, that's not fun for me. But so other places are testing this theory a lot more intense while others aren't. The only way we can figure out what works and what's not is by getting the results. Okay, that's what R stands for, is results. Okay, the only way we're going to know if that's right or not is by determining the data. Does Chicago have more coronavirus cases than Missouri? Possibly. I don't really know. Don't quote me on it. I try not to pay attention too much to it all anymore because it's just chaotic, okay? So you have to look at the results, all right? This is where we are interpreting graphs, okay? Here on the testing, this is where we collect our data, okay? But on the results part, that's where we actually interpret it, all right? We're looking at the actual graphs and creating them, and we're going to compare. Okay, from there, from comparing our results, we're able to draw a conclusion, which is what this C stands for. Okay, and from your conclusion, then we know if we need to restart again, okay, with a different hypothesis, or if we're good to go and the conclusion is solid. Okay, conclusion is, let's say that Chicago has less. Chi-Town has less cases. Okay, that's the conclusion that we drew from our results. So if it has less cases, then we really don't need to go back to the hypothesis and make a new one, because that would say if you wear a mask, then we'll have less cases. But let's say that that's wrong and Mo has less cases. Mo as in us, obviously. Okay, if it has less cases, then our hypothesis of wearing a mask was wrong. Okay, so we need to make a new hypothesis. So the new one could be if you social distance, then there will be less cases, okay? Obviously, guys, we have been running through the scientific method since March, okay? Over and over and over again. Yeah, we've got a couple results here and there, but we still don't have a conclusion, right? Obviously, we're still dealing with it. People are still getting it. So we're just going to, scientists and everybody else around are still going to follow this method over and over and over again. This method applies to everything in our lives, okay? If I brush my teeth, then I won't get gingivitis. The only way to test that is by brushing your teeth or not brushing your teeth, looking at the results, comparing them, and then drawing a conclusion, okay? If you didn't get gingivitis and you didn't brush your teeth, well, then our hypothesis was wrong, okay? And a lot of times it is wrong. A lot of times I think if I eat this bag of chips, then I won't be hungry. That's still wrong. I'm hungry all the time, okay? So you are following the scientific method over and over and over again in your life. It follows you, and that's what it is, okay? So just the big idea for knowing this and why teachers teach it to you every single year is so that way you realize you guys are scientists. You do this every single day, and you do it without even thinking about it, okay? Now, your results might not always be in a graph, but you've interpreted them in your head, okay? A big thing we're going to work on, though, is interpreting graphs, okay? Because we have so much data in science that the only way to understand the next level is by interpreting those graphs, okay? And we are going to get into graphs more next week. This week, what we're going to do more or less is tomorrow we're going to try to look at different labs that have been run, and we are going to pull out the Q, the H, the T, the R, and the C, okay? And we're going to practice seeing it all over again, okay? Then on Wednesday, we're going to learn the different parts of an experiment, okay? Because we will conduct a lot of experiments more in physical science more next semester, but it's still good to understand where a lot of this came from. And that will be like interpreting the independent variable and the dependent variable, and we'll get into that more Wednesday. I'm not going to waste your time today, so that way you forget on Wednesday. And then Thursday we'll practice that, and then Friday you guys will have your quiz. That's that. And then next week we're going to go into interpreting the graphs. We're really going to hit hard on graphs because that is the only way we're able to actually understand what we have been learning. Okay, but next week we will be in class, which is great because graphs are hard if you haven't worked with them too much before. So we'll actually get pretty hands-on with our graphs, and then we'll take another quiz, and then that will be it for the scientific method because, again, we're going to work with it more like us creating experiments more next semester, but it's still good to have this in your thought process and understanding that everything you do is science, and we are always collecting data, whether we know it or we don't know it. Other than that, you guys will have your Padlet with the questions on it, and then we'll meet back tomorrow, and we will do some practice, okay? So tomorrow we'll try to do some practice after you had your lecture today, okay? But other than that, complete your Padlet and have that ready to go for tomorrow, and then I will see you tomorrow, okay? Have a good day.